Okay. In this video, I am going to solve a problem using consistent deformation method. Here's the problem. Analyze the truss shown in the figure. Assume that E is equal to 30,000 KSI and the ratio of length over area is equal to 1 for all members. Okay. So first, let us check the determinacy of this structure. Now, the criteria is this one. B plus R against 2J. B refers to the number of truss members. R refers to the number of support reactions, while J refers to the number of joints. So the sum of B plus R refers to the number of unknowns, while 2J is for the number of available equations. Okay. If we count the number of members, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 members. For support reactions, A is hinged. So 2 reactions, C, 1, E, 1. So there are 4 reaction components. While the number of joints, the joints are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 joints. And we substitute. Therefore, 17 is greater than 16. And so the classification is the truss is statically indeterminate to the first degree. So first degree, it means na we have one redundant. Okay. So this is our original truss. And in using consistent deformation method, we will choose a primary structure by removing the constraint. So from this primary truss, we remove the constraint. So let's choose the reaction at C, the support at C. So let's remove this one. The constraint is at C, the deflection is 0. Okay. So if we remove the constraint, i-remove ang support sa C, we allow joint C, small c, we allow this joint to deflect or to be displaced downward because of this load. Now, originally, there is no displacement since C is, there is a support at C. But since we remove the support, then C will be displaced downward. So this will be our primary truss. And the truss is now determinate. So we determine the reactions, RA and RE. So we sum up moment about A, we can solve for RE. RE is 16, and then sum up force are vertical. We have RA equal to 48. Okay, so we'll solve for S prime. Now S prime refers to the force of members due to real load, assuming with the redundant removed. No? But this is not the true value of the force of the member. So we will use method of joints, or we will use a different style, the labay-labay style, a practical way of analyzing a truss. But the basis is still method of joints. Okay, so we analyze, we start at joint A. Now at joint A, there are 2 members, EB and A capital B. And for this diagonal member, we resolve this into components, vertical and horizontal. Now, in using labay-labay style, we make use of the slope. So how did we get 4:3? We just divide 32 by 24. So 32 over 24, in lowest term, that's 4/3. Or simply 4:3. No? And this is a special triangle. The hypotenuse is equal to 5. So again, for these diagonal members, when we use method of joints, we sum up force along the horizontal and along the vertical. So therefore, since this is inclined, we will resolve the force into components, x and y. Okay. So instead of summing up force along x and y, uh, let's analyze this one practically. Now, we have 48 keeps na force upward. So to balance, or so that the vertical forces become 0, then we have to balance this force, no, by this one. So therefore, the value of this component must be 48 also, acting downward, so that the total horizontal vertical forces will be equal to 0. Oh, so this force must be 48. Now, my way of determining the horizontal component as well as the magnitude is by ratio and proportion. So, for the vertical force, I will divide this one by the vertical value of this slope. So, 48 divided by the counterpart na vertical 4, it's 12, no? 12. If I multiply 12 by this value, 3 horizontal, then I will have 1. That's the value of the horizontal component. So, 48 over 4, 12, times 3, 36. So, this horizontal component is equal to 36. And we have learned sa statics na for components, the arrowhead must meet and for compressive forces, no? And for tensile forces, the tails must meet also, or must come from the same origin. So, to determine the magnitude, we use again ratio and proportion. 48 divided by 4, 12 times 5, 60. And since nadari ang arrowhead, there is adang arrowhead sa magnitude. So the force of E capital B for this member, diagonal member, is negative, which means compression. It's negative 60. Okay. Next, we will balance the horizontal forces. We have negative 36. So we need to balance this force by a force directed to the right. This one. And so that horizontal forces become 0, this must be equal to 36 also. So therefore, the force of member EB for this bottom chord is tensile, positive 36. Okay, so we can say that joint A also is already in equilibrium. Since the horizontal forces is equal to 0, as well as the vertical forces. Next is we analyze joint B. No? So, ilabay na to. Ilabay. We transfer the force to joint B. And since tensile siya, then the force will be directed to the left. Tensile man. Okay. Balance lang. So, this force 36 horizontal will be balanced by this BC. So, therefore, BC is also tensile, positive 36 also. Next, to balance 64 kips, then BB must be tensile, acting upward since the applied load 64 is downward. It will be balanced by an upward force. Positive 64. So, member BB is tensile. Okay, so joint B is already in equilibrium. Next, we proceed to joint B sa top chord. So ilabay, transfer. Since compressive, these are the directions. Horizontal component to the right, vertical component upward. And for BB, tension, so at joint B, it is directed downward. Tension, 64. Okay. Next, for diagonal member BC, we have components again. Now, since this is 64, then this component must be equal to 16 upward so that the sum of the vertical forces becomes 0. 48 upward, 64 downward. Kulang og 16 upward. So this component must be upward. The value is 16. So if we check, the vertical forces, it's already equal to 0. Okay. After this one, we use ratio and proportion again. Vertical 16 divided by vertical 4 is 4 times 3, 12. So therefore, this horizontal component is 12. And to get the magnitude, 16 over 4. 4 times 5, 20. So the force of this diagonal member is 20. Compressive or compression. So it's negative 20. And for this member, BC, let's check the horizontal forces. 36 to the right, 12 to the left. So we need 24 kips to the left para ma-zero. This must be, compressive sa negative 24. After this, transfer to C, labay, compressive. And to balance this force, CD must be compressive also. Same magnitude, 24. And at joint C, there is no other vertical force except CC. So this must be equal to 0. And then we proceed to joint C, small c, having two unknown members. So labay, transfer, labay also, transfer. And then 0. And then for diagonal members, a diagonal member, components, now, we only have 16 downward since this is 0. So to balance, we need 16 na upward. So if we check the vertical forces, 0 na. And same with this one, if the vertical component is 16, the horizontal component is 12. Since they have the same slope, man. Okay. Now, for these components, it means na the force of CD is tensile. Since the tails meet, no? So, tensile na, 20. Same with the other diagonal member, this diagonal member. With components 16 and 12, the magnitude is 20. Okay. Check the horizontal forces. 36 to the left, 12 to the right, 12 to the right. So we need another 12 to the right para ma-zero. So this will be positive 12. So if we check horizontal forces, it's already equal to 0. After this, move to joint D, positive this force will be balanced by dA, positive 12 also. And this one, since there is no vertical force, except this member, so 0 sad. Okay, so for this last member, DE, let's analyze joint E. So at joint E, 11 and 12, and then components, 16 will be balanced by this one, 16 also. And with 16 vertical, the horizontal is 12. So if we check the horizontal components, 0 sad. And the magnitude of this member is 20. Now, another checking is which use joint D. Checking. At D, we have this one, 1612 compression, and then 24 here, compression also, and then this one, 1612 tension, and then 0. So, if we check horizontal forces, 12 to the right, 24 to the right, I mean, 24 left, 12 left, 12 and 12, 24, 0. 16 up, downward, 16 upward, 0. So, these are the values of S prime. Okay. Force of members due to the real load with the support at C removed. After this, we solve for U. U is force of members due to a unit load. Now, since the constraint removed is the deflection at C, so since we allow C to displace, dili tayo mag-apply yung unit load. So we will apply unit load at joint C. So, okay. Let's assume na downward. Okay. So, by symmetry, the reactions at A and E are equal. Or simply, if we sum up moment about A, then we can solve for RA, and that's equal to 0.5. And then we sum up force vertical, 0.5 also. We use the same labay-labay style sa S prime. We'll use the same for this, for this truss, no? Okay, 0.5, i-balance 0.5, and then by ratio and proportion, 0.5 over 4 times 3, 0.375, and then 0.5 over 4, and then the result times 5, it's 0.625, and then 0.375 will be balanced with this, and then proceed to joint V, and then joint V, and then C, and then C, D, and then E. Same with what we did sa previous na slide. So, these are the values. Same style, same procedure as discussed sa previous na slide. Okay. So, checking, same lang. For this member, these are the components, and then 0.75 compression, and then DD0, and then CD, this one, tensile. Check the components. Balance, no? 0.75, 0.375, 0.375, balance. Upward, 0.5, downward, 0.5, balance also. So after this, okay, we are now ready to compute for the values of delta. Okay. Let's contract let's construct this table. So the first column is for members, second for S prime, and then U, okay? These values are taken from this one. So like EB, positive 36, EB, negative 60. And sa U, okay, from this one, values of U. Ang L, this is given sa problem, no? The ratio of L over A is 1. So 1, and E is also given 30,000. So we compute for delta. Okay, sa consistent deformation method used sa Truss, delta is equal to S prime U L over EE. So we multiply this one. S prime times U times L divided by AE. The result is this. Okay, do that up to the last member. So, for all members, same lang is UL over AE. After this, you add summation, the value is this, or the total is this. Okay, next is this delta, the other delta, which is U squared L over EE. So, U squared times L divided by EE. These are the values. Okay, and after this, you add, okay. Now, we already have the value of delta 1 and delta 2. So next, to solve for the redundant, let us use the compatibility equation. The compatibility equation in consistent deformation method is this. Delta, deflection due to real loads, plus delta, deflection due to unit load, times the redundant, which is the reaction at support C. So we substitute these values. So transpose and then divide by this. RC is equal to negative 37.53877. Negative, which means na the direction or the reaction at C is upward. Why upward? Because the assumed direction of the unit load is downward. And since the redundant is negative, so it means na upward. Okay. So after this, we now solve for the true value of the force of the truss members. Now, the true value is this. The S. It is equal to S prime plus U times RC, the redundant. So for EB, we have S prime plus U times this, RC, is equal to this one. So this is the correct value of the force of member EB. Do the same up to the last member. Okay. So these are the correct values of the force of the members. Okay. So this is the reaction upward, and these are the bar forces. Okay. After this, for the reactions, What's the value of RA and RE? Instead of summing up moment about A to solve for RE, and then summing up force vertical to solve for RA, let's use this expression. Values of reaction. R is equal to R prime plus U times the redundant. Now, our R prime is 48. Okay? 48 and 16. So, 48 for this one, 16 for this one. And ang U is 0.5 and 0.5. So, 48 plus 0.5. Our RC is negative. Negative. And okay, the result is 48 plus 0.5 times negative 37.5388. The result is this. For the reaction at A, it's 16 plus 1 half or 0.5 of this negative 2. So therefore downward 2.7694. Okay, so that's it. This is how you use consistent deformation method in analyzing an indeterminate truss having one redundant. So I hope that you have learned something from this. Thank you for watching.